everybody, this is Mrs. Lehman from Math with Mrs. Lehman, and we are learning how to be better shoppers. All right, anyway, so we're on lesson 20, page 55 in your module workbooks. We're going to do some comparison shopping, unit price, and related measurement conversions. We'll get to the measurement conversions later, but today we're going to really just work on finding unit rate. So today I'm actually introducing my students to using a calculator. So I'm going to go through my analogy on calculators. So raise your hand if you have a refrigerator at your house, please. Okay, all the hands are up. What is the job of your refrigerator, Olivia?
Keep everything in the fridge cool.
Yeah, to refrigerate, to keep it cold, right? So your calculator has one job as well. What's the one job of your calculator? Ryan?
To tell you the answers to multiple.
Let me go through this again. A refrigerator refrigerates. A calculator. Help them out, Rihanna.
A calculator calculates.
Very good. It calculates. It will calculate anything you put into it. So, there are some things that a calculator will not do for you. Just like your refrigerator will not do the following. Will your refrigerator go grocery shopping for you?
No.
No, it will not. Will your refrigerator decide on a recipe to use for dinner that night?
No.
No. If there's one out there, I would love to buy it. Is there a refrigerator that will measure your ingredients out for you? No. Is there a refrigerator that will cook your food for you? No. Is there a refrigerator that will then serve the food, put it on a plate and serve it to you at your table?
No.
Not a chance, right? So a lot of times kids get calculators and all of a sudden, you know, their expectations of this calculator are through the roof. They think this calculator is going to answer questions for them, is going to do all this stuff. You would never expect your refrigerator to do any of those things that we just talked about. So you can't expect too much from the calculator either, all right? So your calculator is not going to read each question for you twice. Your calculator is not going to underline the keywords for you. Your calculator is not going to pick out the correct numbers to use for your calculations. Your calculator is not going to decide which calculation to do. Your calculator is certainly not going to label your answer and show your work, right? It's not going to do any of those things for you. It will simply calculate. So if I were to put garbage into my refrigerator, what am I going to have?
Cold garbage.
What, Michael?
Cold garbage.
Exactly. So you could type in numbers in this calculator and you may think you're, I just, golden pass here, I don't have to do any thinking. You would type in numbers, it will calculate whatever you type into it, but it could, if it's not the right numbers or you're not thinking about that correctly, you're going to end up with a garbage answer. So I just want you to be warned on the calculator usage. It is simply a calculator. Yes, Olivia?
Throughout the trash and the garbage, you also get a really smelly refrigerator.
That is true. Now, on that note, we're going to move on. All right, so we are going to pretend for a moment that we are personal shoppers, okay? We're going to help people go shopping because there are some people who maybe don't know this skill and they want to save some money. So we have been hired as a layman consultants. We are going to go with these people to help them save money by making some simple decisions based on calculations of unit rate, okay? So our first client, I should say, is Mallory. She is on a budget. She wants to determine which cereal is a better buy. And better buy means you're looking for the best price. A 10-ounce box of cereal costs $2.79. I'm going to have to underline that because my calculator simply won't do it for me, all right? And then we also need to underline this part. It says a 13-ounce box costs $3.99. Which box of cereal should Mallory buy is our big question. So we want to save her money. Are we looking for the highest or lowest unit rate when we are trying to save money? Lowest. Very good. So we want to find the price per ounce, right? So what number, when I do this division, do I want to put on top? Do I want to put the money or the ounces? Liliana, nice and loud.
Money.
Money, very good. So if you want the price for something, you want the price per ounce in this case. So it's $2.79 divided by, make sure you've labeled that one, by the way, with a dollar sign in front. And we are going to divide that by 10 ounces. Okay? And try not to make that look like 1,002. Make your letter O smaller, but put the little slash to the Z so it doesn't get mistaken for a 2. All right? Neatness is important. So now we know that this fraction bar means what operation? What operation? Division. Very good. So 279 divided by 10 ounces. Now when we divide by 10, that's really a simple calculation because we get to slide that decimal point one to the left. So what you're going to end up with when you divide is 0.279 per ounce. All right, $0 and 279 thousandths of a cent per ounce. All right, so did I say that right? 279 thousandths of a dollar per ounce. All right. We want to round to the nearest cent. So cents are 2. That's the nearest penny right here under the 7 would be the penny spot, right? 1 cent. So we're going to look at the 9. If it's 5 or above, we're going to bump that up to 28 cents. If it's 4 or below, we're going to keep it at 27. So what do we want to do with this one? Make it 27 or 28? Everybody?
28.
28, very good. So we're going to write approximately, that's what that symbol means, $0.28 per ounce. All right? So on for just one single ounce, it's going to be 28 cents. Let's look at the next box of cereal. What am I going to put on top? Who can tell me? Maddie.
$3.99.
Very good. $3.99 because I want the price per. And then what would I put on the bottom? Olivia?
13.
What? 13. Very good. I thought you said 15%. 13 ounces. Okay. So we are going to utilize our calculators now. So make sure you turn them on. What you want to do, just like if you were to buy a used fridge, right? You'd want to clean out the old person's crumbs and stuff. You want to make sure when you start using your scientific calculator at the beginning of class, not between each question, you don't need to do this level of clearing, but if you want to just, when you start using this at the beginning of a period, on and clear at the same time for this model calculator that we're using, will tell you memory cleared, right? Mem cleared, and that means it just took whatever weird settings the last kid managed to do, right? We've used Chromebooks before, and we know that some kids get quite the kick out of changing the language or putting something weird as a setting. This is going to do the same thing for our calculator as far as resetting it from those things, right? So between problems, we can just clear it. Anyway, that was long-winded. $3.99 divided by 13 ounces. Go ahead and do that. And I'm going to bug Evan for an answer here. Evan, go ahead and enter that in. I don't know what you pushed on there. Oh, you got to clear that out. Okay. Yep, start with a clear screen, okay? So type in 3.99, 3.99 divided by yep, 13 equals. All right, so you got a really long number there, right? So it comes out to $0 and what was it, 309 something?
306.
306. All right, and it keeps going and going. When we're using money in 6th grade, we're gonna go pretty much to the third one out because then we can round to the nearest penny. The second one past the decimal. Okay, so we're gonna go to the thousandths place to round to the hundredths place. So here's where we're rounding to, right? So we gotta look behind it. So that's going to be approximately what? What would the answer to that one be? 31 cents, right? So $0.31 per what? Per what? Ounce, yep. You don't have to be creative on this. It's right here. Right? There's the ounces. All right. What's the difference between the two unit prices? What's the difference? What operation does difference signal us to do? Difference means to do what operation? Anaya? Subtract. You want to say that in the microphone? No, she's being shy. All right, subtract. So, excuse me. So we're going to take $0.31. We're going to subtract 28 cents. When you are adding and subtracting decimals, you need to line up your decimal points. Right? When you do that, you are going to get a difference of $0.03 savings per ounce. So you're going to save that on every single ounce when you go ahead and buy the 10-ounce box. All right, so let's put a big star by the 10-ounce box because that's what we're going to direct our client Mallory to do, to buy that one, okay? All right, let's move on to question 58. We've got Mitch now. He's wondering which soda pack he's going to buy, and he's trying to figure out if it is cheaper to buy the 12-pack or the 20-pack. The 12-pack costs $3.99, 20-pack costs $5.48. We've got to figure out which pack he should choose, so make sure you go ahead and underline those key things. Let's set this up. So, we've got a 12-pack for $3.99. Which of those quantities am I putting on top? The money or the number of cans? What goes on top when we're dealing with this?
Money.
Money, yep. All right, so we're going to put $3.99 on top, and we're going to divide that by 12 cans. All right, so go ahead on your calculator. Once you have all your labels written down, again, I expect that everything that I have written on the board you're going to write down too, because that's the format I want to see on your homework. You're missing a decimal point in that, so make sure you're looking at your screen. $3.99 divided by 13, by 12, not 13. Jeez. All right. And now that I'm done telling you the wrong numbers, 0.3325. So we need to round, right? So we're looking to round it to the nearest cent. We've got to look to the thousands place to do that. So that would be approximately how much? Guys, what would that be? 33 or 34 cents? 33 cents, right? So $0.33 per what? Not per ounce, per can in this case. All right, so that means you're going to pay 33 cents for every can in that pack. Let's now calculate the 20 pack. So you're going to set that up with the money on top, $5.48, divided by 20 cans. Go ahead and type that into your calculator. And what do you get when you do that? Jenna, nice and loud. Very good, 0.274. All right, so again, we only need to go to the hundredth spot right here, so we got to look behind it. 5 or above, give it a shove. 4 below, we let it go. So that's going to be approximately how much? 27 or 28 cents? Which one? 27 cents per can.
I only got 27.
What do you mean?
I only got 27.
Because you don't have 0.48. All right. What is the difference between the cost of 1 can of soda between the 2 packs? What's the difference in the price here? What operation are we going to do to find the difference? Ryan? Subtract. Yep, that word difference means subtract. So we are going to take $0.33, and from that we will subtract out 27 cents, and that is a difference of how much? Ryan? Very good, 6 cents. So you're going to save 6 cents on every can, right? So if he had to buy, you know, something like 120 cans of soda, he's going to save a lot of money over the course of, or by buying that cheaper pack per can. So the 20 can pack is going to be 6 cents cheaper on each can. All right, I'm going to have the kids work on this next one on their own, and I'm going to get them set up for their homework tonight. So I'd like to thank you for watching, and don't forget to subscribe. I hope you have a wonderful day. Bye.